Alright, in our last few videos we've been looking at this Pong program, and I'm doing it in a style called object-oriented programming, where you make a class and the class makes an object, and it has two things. It's got the data, usually numbers, of where it is, where it's going, what its name is, and then it has methods of things it can do, sometimes called behaviors. They take that data and move it or change it or display it, or when it gets really interesting, interact with another object. So that's why Pong is a good example, because you have the ball and you have a paddle, and most of the time they're separate. The ball is doing its own thing, it doesn't care about the paddle, but now, boom, it bounces, and for that moment they have to know something about each other. The ball has to know where the paddle is to know whether it changes direction. And in our first draft, which you see here, we did it in kind of an ugly way, where the ball has its own data and then it also reaches in to the paddle's data and says, hey, tell me your x, tell me your y, tell me your height. And the paddle says, why do you want to know? And it says, none of your business. That's usually a pretty messy way to do it. It works, kind of, although this has some bugs, and ideally we'd organize something better. Now, I wanted to say that this is not the only way to do it. You could achieve the same thing without classes. And in fact, in an example, I took out the classes, and just for fun, I went overboard and took out the functions too. So this is one entirely united namespace where everything is floating around together. And if I hit run, this version looks exactly the same. It works the same at the same speed, and you would never know that the code is different. It even has the same bugs, and sometimes it bounces off screen and you can get it to come back. Didn't work that time. And sometimes it gets stuck inside the paddle if it lands in just the wrong angle. And those are the same here because the math is the same here. It's not doing anything different. It's just arranged in a different way. I kind of use the metaphor of papers on a desk. If you have a bunch of papers sitting around, you could put them in a folder, and they're the same papers with the same stuff, but now they're organized. In some ways that's good because it signals that they're related. In some ways it's bad because now you have one extra step. To get to them, you have to open the folder. And for a small program like this, it's probably fine. I can sort of hold the whole thing in my head and make sure there are no mistakes. And if I were to save this on a device with limited memory or something, maybe this would be the way to do it, sort of like the original Pong. But if I were going to share it with other people, edit it later, add another paddle, add another ball, change the rules, this would be pretty hard to mess with, because if I change something here, then it affects all the other stuff everywhere else. In this version, where, at least in theory, if we do it right, things are encapsulated, things are separate, so that when the main function, for example, says ball.update, then it doesn't really care what's inside the ball. It just says, hey ball, you do your chores, you do the stuff you need to do, and you take care of it. That's kind of nice, especially if there were multiple people working on this project, and it wouldn't have to say like, hey, what are the variables inside of your thing called? No, you'd come up with some nicer interface. It's not the only way to go, but it's often a reasonable way. So I wanted to say, let's take what we've got and go one step further for the sort of final phase of this draft. Where we left off was a two-player version, and it looks like what I just showed, except there's one on the left that moves with W and S, and there's one on the right that moves with up and down. And they are identical paddles. They're instances of the same class, except I had to tell it, hey, if you're left, then use W and S. If you're right, use up and down. That's pretty janky. In a later version, I'll have the input handled in its own section, and then it will just tell the paddle, hey, you need to go up. You don't need to know why. You don't need to know what the button was. Just you need to go up. But anyway, that's fine for now. And what I had to change, and I showed this in the last video, was the collision. It was so ugly to say, okay, we're going to use our stuff, add some, compare, use their stuff, mess around. This was really bad, and the one on the left is even worse because of the way the paddle starts its measurement in the top left, and we have to go to the top right to hit the right edge of the blah blah blah. No fun. So we ended up making a little collide method on the paddle to say, hey, am I touching you? And it says yes or no. That's cool, but I want to go one step further today and say, Pygame was made with this in mind. They knew we were going to do this because when you're making a game, you have to decide if Mario hits the Goomba or if your guy bumps into a wall. And so they have collision pre-baked. We're going to use that instead of our version. So the way to set that up is to set up a rectangle. They use rectangles a lot in Pygame, and it's based on the fact that the math is easy. Like when we did our paddle, well, the math is pretty easy to tell if you're within the X range and within the Y range. Now, that works, and we're going to give our ball a square hitbox because it works for now, but later we'll have to refine that. I'm sure you guys have heard of the concept of hitboxes in games where sometimes you watch the boss's sword fly by and you think it shouldn't have touched you, but you really lose health anyway. Or you're playing a fighting game and you have to think about, okay, how far does this punch reach versus the other guy's kick or something. So we're going to give our ball a hitbox that doesn't look like it, but what's shown on screen is not always the same as what's happening in the math. And that's important to know. It's just like in our earlier programs when you would do some stuff and then hit print. Well, the print is not everything. The print is not the soul of the data. The print is just one expression of it. And the draw, whenever I have the ball moving around, that's just one expression of the data we've got. So let's say I want to do a rectangle for the paddle. That's easier because it already is one. And in fact, we've already typed up how to make it. Right here, this is the Rect. This is using the Pygame Rect class to make an object, just like we're doing with our own classes, but I'm going to abstract it out and make what's usually called an alias when you take a big thing and give it a nice name. So self.rect equals this whole thing, and then we can say self.rect, or at least we think we can. It's not going to work completely, but I'll show you in a second. So this is saying, okay, self.rect is starting in the top left, going over, going down, and making that shape, and then we can use that. However, it doesn't work because it's set in the init, and it's based on what the x and y are, so when I'm pushing up and down in W and S, they're not actually moving like they did a minute ago, even though they are in terms of the calculation. You saw it bounce off the bottom because it was actually theoretically there. So how do we change that? Well, we just need one line to say, hey, rect, update with the move. And now this move is getting even uglier, but like I said, we're going to fix that in a later draft. So now it updates the rect based on, did we go up and down every frame? And now it works based on the same stuff we had a minute ago. Zero change in the functionality, it's just a little nicer in some ways because I can say self.rect anytime I want instead of saying this whole guy. But that's not the benefit. The benefit is that I can use the methods of that class, and that class was made to be used in this stuff, to have objects bumping off each other in the game. And when we have them collide, you can take damage or die or whatever. So now, instead of this collide that I made, we can delete it because the rect already has one, and it's better. And instead of this stuff, we can use a slightly different setup. But what I want to do is give the ball a rect as well, which seems a little funny because it's not. But it's going to have a hitbox. In fact, let's go ahead and call it hitbox. Why not? You don't have to call it rect, although that's standard. And so we're going to say pygame.rect with a capital R because it's a class. And it's going to go, xy. And then height and width, except we don't have a height and width because it's the circle. So we have to do something kind of goofy, which is like go from the center a little bit left and a little bit up. And I know this sucks, but we'll never have to type it again. And then go 2 times the radius over. And yes, I see that this line is very ugly. But what it means is we got a circle and we go up, up, and we draw a box around it. And this works because our current version only bounces at the very top of the circle, the very left, the very right, or the very bottom. It's not hitting at weird angles. We'll get to those later. The real Pong has different angles depending on where you hit the paddle. Like the middle of the paddle is one thing, and the top is another, as a sort of spin physics thing. But ours is not there yet. And once it is, we'll be smart enough to create a new hitbox. So now we're going to say, all right, we have a thing that's built in to the rect, and it's called collide rect. Very easy to remember. And you give it 2 rectangles, and then you say, hey, are these touching? Yes or no. So we're going to go self.hitbox, and then, oh, you just give it 1 because it's already based on 1. It's already sitting in 1. And then we're going to do the other guy. And then we're going to say, in the last video, I made a little silly method to give us the point of the left or the point of the right. We don't need those anymore. And the rect has some built-in properties. We could say top left, right middle, or whatever, and it would give us the point. Because that's often what you need. Like if you want to tell whether Mario is touching the ground, you can say Mario.rect.bottom or something, and it'll give you that y coordinate. So this is cool. I think it's going to work unless I made a typo. Oh, I forgot one thing, which is the self.hitbox should change when we move, because it's just like the paddle thing. We want to calculate what's happening behind the scenes and what's happening on screen as separate little things. Now if I hit run, I'm going to see that there's no difference. I'm still moving the paddles, I'm still moving the stuff, and it bounces exactly the same as it did. Maybe slightly better because their rect collision is going to be slightly better than mine, but no big change. However, now we have a much nicer setup for the future, where if we want to test, is it off screen, for example, I want to say like, oh, is the ball off screen, then we can make it disappear or make it teleport back to the middle and start a new round. We can use the rect. We can use the rect to have all those points like top left, bottom, middle, and we can also use some other stuff that's in there. And later, when we have the better visuals with images and sprites, we won't even have to make the rect, because when you give it an image, Pygame can automatically draw a rect around it for the hitbox. And so we won't even have to do this part, which is admittedly very ugly. So we're helping ourselves for the future by getting ready for what's going to be, even though this version performs about the same. Like I said, I think it's a little bit better because I'm sure they wrote something slightly better than I did, but it's not a huge deal. The next step, IMO, would be getting the input handled, but I want to stop for now and say this is our sort of first draft wrapped up. If you get the single player and then the 2-player, and then we get some of this collision really going through the steps from ugly math to homebrew method to pre-baked method. Now we're getting somewhere, and that'll be the end of our school year. Thanks.